Hey guys, today we're going to talk about 7.1 Intro to Circles. There's a lot of vocab in this unit, a lot of different formulas that you're going to have to know in order to be successful in this unit. So this is just an introduction to what a circle is and the parts of a circle. In this first part here, what I recommend is I've put up a form that has basically you can write the definitions for each part. I think I called it Introduction to Circles. 7.1, it's a Word document. What I recommend is going through 7.1 vocab on the Quizlet and writing down those definitions. So have those definitions with you, print them out, write them on a piece of paper. That way you kind of know what's going on before we talk about the rest of this unit. But for the notation, I am going to go over that. So if I'm looking at this circle, the center of the circle, let's call it A. So when I'm notating a circle, I call it circle A. That's pretty easy, right? The diameter, we know, is the line that goes through, has two endpoints, and it goes through the center of the circle. Okay, that is going to be, let's say, point B, point C. So we name it BC. Make sure that you have that segment over it. The diameter is a segment. A radius, obviously we already started to know radius. That again is also a segment. So we have two radius in this situation, or two radii. We have AC, and another example is BA. So there's going to be a lot of different examples when I have a lot of lines going through all my circles. Now a chord is a line or a segment that goes through two endpoints, and it cuts the circle inside. It is also a segment, so let's call that EF. Now something to make note of is that a diameter is also a chord. So the diameter BC is the longest chord of the circle. So the diameter is the longest chord. And that's because it exceeds the length. It is the longest possible distance between those 2 points. Now we have something called a secant. So a secant goes through the circle, hits the circle in two places in the inside, but it's a line that goes through the circle. So we have like G and H, so that would be a line GH. And a tangent touches the circle in one place. So it touches just like, let's say, here's a point. It's on the outside, it's a line on the outside, and it only hits the circle. Whoa! It only hits the circle in one place. So let's call this K. So that's line K, and usually you have another point on the tangent like KL, so KL. So secants and tangents are lines, chords, radius, and diameter are going to be segments. All right, so now we have some different types of angles that you're going to start to learn. We have the inscribed angle, and what an inscribed angle is it's an angle formed inside where the vertex of the angle is on the circle. So when you name these, you have to name them with 3 letters. So we'll call that angle A. B is the vertex, so the vertex is always in the middle of the angle measured, or the angle naming. A central angle is formed when the vertex is at the center of the circle. So here, we might have angle E. F, again, is the vertex at the center of the circle, C. So this circle is circle F. Then we have a major arc. A major arc is over 180 degrees. So if I have a diameter, here's my diameter, then I'll have an arc that goes a little bit further than, it can go significantly further, but it's bigger than the length of the diameter. So let's call that, let's call this K. So it's major arcs are named with 3 letters. You've got a little arc symbol above, just like the segment in the line. And we'll call this KAB. Minor arcs don't necessarily need 3 letters. The reason I need 3 letters, let me kind of backtrack, is KAB. I kind of can think about different ways to get it. So this KAB tells me the direction of where to go. A minor arc has 2 letters. That's going to be less than 180 degrees. So for example, this guy is less than 180 degrees because he's less than the diameter. So that's going to be arc AB. A semicircle is the entire length of the radius, the arc that forms the radius, or this diameter, forms the diameter. So that would be like this guy right here. Let's see. That's going to be hard if I'm erasing. That length. So if this is the diameter, it's the top of the diameter. And that is a minor arc symbol, so you only need 2 letters, km. Because km is the same measure if I go to the left or if I go to the right. All right, so let's try some identifying. So the radius here, I have a radius AH. Remember, it's a segment. The diameter is HF. A secant, the line that goes through, so we have BD. The tangent touches one point on the outside of the circle, so that's like HJ. A chord could be segment CD. So I could name the secant CD, and I could also name a chord CD. The most important thing is that you notice the notation at the top, so be careful there. Major arc may be like DHG, so arc DHG. So follow that along, see where that goes. DHG, that is definitely more than 180 degrees. A minor arc may be arc DC. He's a little guy right here, DC. And then we have a semicircle that's formed by the diameter, so semicircle maybe could be like HF. All right, and on the flip side of that, we have taking the notation and being able to identify what it is, which is right here, which is right there. So we'll get to that. All right. A central angle is the angle whose vertex is on the center and whose sides are the radius. We talked about that. The vertex is at the center. The arc between the endpoints are called the intercepted arc. So this is the arc. Kind of think like a baseball field. Like that's the fence of the baseball field. And the angle that goes with it is the inside angle, so where you would put home plate. The arc measure of the intercepted arc of a central angle is equal to the angle's measure. Angle measurements usually are written outside, so if this is like 65 degrees, that's the angle measure, or that's the arc measure, and the angle measure is also 65. So measure of CE. So here we have CE. It's formed by the central angle. So that means that the arc CE is also 45. DAF. So DAF, I have the arc of that, but not the angle, but because it's a central angle, that means that the angle is 30 degrees. Measure of EF. Okay, here's kind of the fun part. So this right here is a semicircle. This line is a diameter, which means that this is a semicircle. How many degrees are in a circle? 360. So half of a circle has 180 degrees. So if we know the 45, we can subtract that out. And if we know the 30, we can subtract that out. And that'll give us the remaining measure that's within that arc. 180 minus 45 minus 30. So that's going to be 105 degrees. So all of these are measured in degrees. Then we have BD. Some more fun things that start to happen is you'll notice that this relationship between this angle is something that you've seen before. It's called a vertical angle. So if this is 45, that means BD is also 45. But we could also do the same thing. We've got, I know I'm drawing a lot of different colors, so it's kind of hard to keep track, but we've got here a diameter. I know the 105, I know the 30, so then I would just have to find the 45. BAD, that angle is equal to that arc, so that's also 45. And EFD is the combination of this 105 and this 30, so it's the entire length, so that's 135 degrees. Okay? All right, now we got some examples of some central angles, kind of some algebraic problems that you're going to have to be able to do. So if we want to find the value of x, this angle is going to be equal to this intercepted arc. So that means I can just set those two measures equal to each other. Subtract 3 over. Whoop. So 112 equals 14x. Divide by 14. Divide by 14. 112 divided by 14 is 8. Okay. If I want to find x here, I know that this right there is the diameter, which means I know this arc measure. That arc measure is 180. Therefore, if I add the 56x minus 1 plus the 34x plus 1, and I set it equal to 180, I can solve for the x. Combining like terms, we have 56 and 34. So 56 plus 34 would be 90x. Minus 1 plus 1, that cancels out, or that plus 1 minus 1 becomes 0, equals 180. Divide by 90, x equals 2. Okay. And our last example, kind of like sonar, like dolphins. When the dolphins are swimming, they do sound waves. So if measure of BPA is 65, so BPA is 65, what is the measure of IH? These are all intercepted by the same central angle. So even though the circles are getting bigger, the ratio of the central angle to the arc measure is still going to be the same. This is still a central angle, so it's still going to be 65 degrees. I guess those are called sonar dolphin waves. I don't know. All right, so if you have any questions, make sure to reach out. This is just a basic intro day. We're going to get into some heavy angle measurements